All right, 2 examples, and then we'll get you guys started on your work. All right, looking at number 5, okay, you're given an equation. It says a car's gas tank contains 4 gallons of gas, okay? A pump can be filled at a rate of root 10 minus t gallons per minute for 10 minutes. How many gallons of gas are in the tank at 5 minutes? Sketch a graph and label the units. Okay, so what I want to know is, here's the question, how many gallons of gas are in the tank at 5 minutes? I'm going to highlight some starting information. It says that a car's gas tank contains, right, so I'm starting with 4 gallons, and then I'm going to go to the pump, and I'm going to add gas for 5 minutes. Okay, so if the sketch, okay, I'll let you type that in your calculator to graph it. So this is the graph of R of t, and I'm going to label my units. This is minutes. This is gallons per minute. And I'm going to type it in, and I'm going to sketch this. Okay. Root 10 minus x. Okay. Okay, root 10 minus x. Okay. Window 0 to 10, because it says 0 to 10 minutes. Now I have an idea of what this looks like, but I'm just going to do quadrant 1 and see. Oh, window range. Oh, 0 to 10. Scales by 1. Scales by 1. Okay. So it looks like it's starting at about 3 high, just less than. And it looks like it's at 0 at 10. Just a rough sketch. Okay, how do I answer the question? It does not tell you what to do. But if I want how many gallons, you have to look at the information available. I have gallons per minute and minutes. If you want total gallons, you do the definite integral. 0 to 5, because it just says at 5 minutes. It doesn't say at 10. It says it for 5 minutes. Okay? R of t dt. Now I'm going to put an equals, not an approximation. It didn't say draw rectangles. Just said find the gallons. And you had 2 choices, home screen or graph screen. Home screen or the graph screen. I'm going to do it on the graph first because that's where I'm at. So second trace number 7. Second trace number 7. Start at 0, stop at 5. Yep. Okay. Start at 0 for lower, stop at 5. This shade's about halfway. Okay, 13.62. Okay. Second trace number 7. 0, 5. And I end up with 13 point, I'm going to say 63. But we haven't actually answered the question yet. I just found the definite integral. I'm going to do on the home screen. Quit. Okay. Math number 9. That's where I get the F int, and that's where you get this screen. 0 to 5. Root 10 minus x. Same answer. It doesn't matter where you evaluate this, but if you need the exact answer, you do it on the home screen or the graph screen. Home screen might be easier because you're not worried about the window. Okay, so that was math, number 9, and then I'm going to let you fill it out from there. Okay. Let's answer our question. 13.63 was the total gallons added in 5 minutes. Have I actually answered the question yet? Anyone know? I'm going to go with no. So read it again. Start at the beginning. Read the information and see if you can figure out what the answer is. One person. We'll wait for somebody else. 2, 3. That's it. 17.63. All I did is find the amount of change, but I actually started at 4 gallons. So make sure you're reading the questions carefully. And so the answer, 17.63 gallons. We started at 4, circled in red, and we added 13.63. The integral only finds the amount of change. It doesn't take into account how much you started with. Okay. Ready? Turn the page. We're going to do example 6. Okay. The graph of velocity in feet per second and seconds. Right? I like to label my units bigger. Okay. From 0 to 50 seconds, and there's my table of values. Okay. 5 seconds each. Okay. And there you go. This is the graph. Those are the points. You don't have to guess any of the values. During what interval of time is acceleration positive? There's the question. Write down acceleration units right underneath of it. Okay. Acceleration is feet per second squared. How do you get from velocity graph in feet per second to acceleration? Slope. Okay. Velocity to acceleration is slope. Okay, I'm connecting the graph I have to the information I need. So let's read the yellow part again. But instead of saying acceleration, we're going to say slope of velocity, because that's what it is. Slope of velocity positive. Now answer the question. Based on the picture. Okay, there's your sentence. Fill out the missing pieces. We did a bunch of reasoning, right? A bunch of sentences on your last quiz. That's what you're thinking about here. The equals are not important. What goes in each of those blanks? 0 to 35. There it is. Slope is positive 0 to 35 and 45 to 50 because V prime is positive, because that's what I was looking at. I was looking at slope of velocity. Well, that's the mathematically correct way to say it, V prime. The derivative of velocity was positive. Acceleration equals V prime. Okay, find one approximation for acceleration at t equals 40. Okay, well, instead of acceleration, I'm going to say slope of velocity. Can you estimate slope of velocity at t equals 40? At t equals 40. I'm going to circle it in red. There are 3 possibilities. Come up with one. Slope at the red dot. Now you have to use points on the graph. You're not allowed to guess any values. So I could say this line, or this line. Pick a tangent line up there. Okay. So 1, I'm going to do t equals 35 and 40. Maybe I do t equals 40 and 45. Maybe I do 35 and 45. Anything that surrounds the t equals 40. Little bit before, little bit after, a little bit around. Negative feet per second squared. Same units. Doesn't matter which estimation. It just said find one. As long as I can see where the work came from, one estimation is good. Notice that it does get a little bit more steep on the right side of that point, which you can see by the -3. Little less steep, little more steep, something in between. Okay, part D is the review part. See if you can set up part D. That's your Riemann sum. So you've got your table. You set up part D.
so there's 3 data points per record. So the data point is not necessarily a consistent delta x, it's more of a consistent number of data points that you're using. It's a definite intervention. We're actually calculating the number. It's like finding the slope out of point. It's a number. That is worksheet 6, which is not a number. But we do that. But we do that.
All right, guys, you are setting this up. So
Basically, I already broke the original is like I still carry my
You actually like so
And I say, what's about the letter?
Do you read it in front of me?
Now there's a vertical shift that looks like disappears. This is
You're testing me. He really asked me. I respect it. I still look. Yeah. I respect like other animals like dogs. Is that what the letter said? Just like, yeah. Start building
this is how that start with the height. We're doing it areas. There's an outlet. That's where she's not there yet.
all right, let's take a look at last part. Okay, so Riemann sum. Here's my integral. Approximate. Riemann sum. Midpoint 5 subintervals. Now it does say of equal length. Okay, so 50 minus 0 over 5. So I'm looking at a delta x of 10. Okay, now try to draw it without actually making the graph. The definite integral of velocity will be approximately something feet. Because I can already multiply my units. Now I need 5 rectangles. 1, 2, 3, 4, 5. I have 5 rectangles. Now I have a delta x because they said equal. And so I have equal, so that's 10. 10 times. 10 times. Okay. Remember, your delta x's don't actually have to be the same. Just based on the divisions in the table. And so now I'm going to zoom out and I'm actually going to look at my table. Okay. So my delta x is 10. And I'm going to try to draw my rectangles on the table of values. Notice that each of my rectangles has 3 data points. Now I could extend them, so I'm going 0 to 10 and 10 to 20, 20 to 30. Right? I don't need to draw a graph to get rectangles. And it wants midpoint. So I'm going to circle the middle y value. I'm not averaging anything. I'm doing the middle y coordinate. And so 12, 30, 70, 81, 60. Those are the numbers that are going to come down here. So it was 12, 30, 70, 81, and 60. And multiply, okay? Two, 5, 3, 0. And I do know that my units reduce and I get feet.